So in this video, I want to show the relationship between the clusters that my algorithm develops and the video that's the source of those clusters. Here, that lets us load up a video. So this video was recorded by one of my robots driving around one of our computer labs here. And in the first couple frames, it was washed out a little bit, but now it's looks a little clear here. And you can see it's a pretty basic lab, tile floor, doors open, boxes cluttered, chairs around, and so forth. So let's go ahead and train it to have 32 clusters. This will just take a moment. Didn't get around to actually threading the interface, so it just took a second, but now it's working just fine. I'm going to click on here to show the best node, and so the idea is as we advance through the video, it's going to show what the reference input for the best matching cluster looks like. And so I'm going to go ahead and just play through the video a bit, and I want you to notice how the reference inputs correspond pretty nicely to being an average of the appearance of the surrounding inputs. Here we just had a nice little transition. So now we're in this cluster, it turns around, now we're in a new cluster, and as we get closer and closer, we see reference inputs that correspond to different intermediate views of what it looks like. So this is a really nice example here. So we got closer to the chair there. It's about to switch again as we get even closer. And so the clusters really do a nice job of dividing up the video stream into related components, related views that really mesh together nicely. Down here you can see both the index of the cluster and the total number of images that were used to create its reference input. And so here it's starting again, so like this number 1 had 19 original inputs, that one had 25, and so forth.